This video is about the mole and molecular mass. So our content objective, I will understand the concept of the mole and use it to find molecular mass. Take notes from a video, practice with our partners, and in groups. So the mole is a counting unit, similar to a dozen, except instead of 12, it's 602 billion trillion. And we truncate that or make that smaller by 6.02 times 10 to the 23rd, and that's in scientific notation. It is named after Avogadro, who studied quantities of gases and discovered that no matter what the gas was, there were the same number of molecules present. So the mole is equivalent to 1 dozen cookies. So 1 dozen is 12 cookies. 1 mole of cookies is 6.02 times 10 to the 23rd. So as I was saying, 1 mole of cookies equals 6.02 times 10 to the 23rd cookies, if we're talking about moles. So again, as 1 dozen cars is 12 cars. A mole of cars would be 6.02 times 10 to the 23rd cars. So here we are, chemistry, 1 dozen aluminum atoms, it's going to be 12 atoms. A mole of aluminum atoms, 6.02 times 10 to the 23rd atoms. Okay, so the number may be the same, but the mass is going to be different. And we abbreviate mole just to MOL, just because we don't want to confuse it with the animal. So if we invented a new collection called a wrap, 1 wrap contains 8 objects. So how many paper clips in 1 wrap? Wait for it. Okay, so we would have 8 paper clips. So how many oranges in 2 wraps? So 2 times 8, 16. And then how many wraps would we have if we contain 40 gummy bears? So 40 divided by 5 would be, 40 divided by 8, is 5. So a mole of particles contains 6.02 times 10 to the 23rd particles. So 1 mole of carbon, 1 mole of H2O, 1 mole of NaCl. So each one will have 6.02 times 10 to the 23rd atoms, or molecules. So whatever it is, if it's a molecule, if it's an atom, it's going to be that number of particles. Okay, and if you notice, we can break it down into that number of ions, positive ions and negative ions, and when you put them together, it'll be this 1 mole molecule. So Avogadro's number as a conversion factor, we either put 6.02 times 10 to the 23rd particles over 1 mole, or we put 1 mole over 6.02 times 10 to the 23rd particles. Note that a particle could be an atom or a molecule. So we have a number of atoms in 0.5 mole of Al. So if we have half a mole of aluminum, how many atoms do we have? Well, 0.5 is half, so we cut it in half, so the answer is C. So number of moles of sulfur and 1.8 times 10 to the 24 atoms. So all we do is we take this number. Okay, so in this case we're given 1.8 times 10 to the 24th atoms of sulfur, but a mole is 6.02 times 10 to the 23rd. So we take this number, we divide it by 6.02, and that gives us 3.0 moles of sulfur atoms. So now we're going to move on to molar mass. So the mass of 1 mole is in the unit of grams. So it's equal to the numerical value of the average atomic mass, and we're going to get that from the periodic table. So 1 mole of carbon atoms is 12 grams. For magnesium, 24.3. For copper, 63.5. So we're going to find the molar mass of bromine. So by looking at the periodic table, we notice that the mole of bromine is 79.9. Okay, and also by looking at the periodic table for tin, we notice that the mole of tin is 118.7. So we're going to find the mass in grams of a compound. So we have a 1 mole of CaCl2, and we're saying it's 110.9 grams. And we get that from 1 mole of calcium is 40.1, and we have 2 moles of chlorine at 35.5 each. All we do is multiply and we add it, and that's going to give us 110.9. So in this case, we have N2O4. We're going to say it's 96 grams. Alright, there we go. So there are 2 nitrogens, so we do 2 times 14, that's going to give us 28. And then we have 4 oxygens, which is going to be 4 times 16, and that's going to be 64. 64 plus 28, that's going to give us a total of 96. So when we calculate molar mass, we should be able to go from grams using the molar mass to go back to moles, and vice versa. So converting moles and grams. Aluminum is often used for the structure of a lightweight basketball. So if we have 3 moles of aluminum, how many grams is that? So if 1 mole of aluminum is 27 grams, we're going to use our conversion factors. So if we're trying to find the number of grams, we know that 27 grams of Al is going to go on top. And then, because we need to cancel moles, so 3 times 27, and that should give us our final answer. So that'll be 81 grams. And that's it. So we'll go over more problems so you guys understand this better.